box is pulled up a frictionless incline by a rope at a constant speed. If the weight of the box is 40 newtons and the incline is angled at 64 degrees, what is the tension force? So diagram. We've got our incline, 64 degrees, and you've got your box being pulled by a rope up that incline. Given values. We know that the weight of the box is 40 newtons. Be careful, that's weight, not mass. If it was mass, it would have been kilograms. We know that the incline is 64 degrees. So our theta will be equal to 90 degrees minus 64 degrees. Remember, anytime you're at an angle of incline, your theta that you're using to get x and y components is 90 minus that angle. So theta will equal 26 degrees. We know that it's moving at constant speed, so our forces will be balanced, and we're not given anything else, and we're not going to need it. What are we looking for? The tension force. Force diagram. Here's my incline. Gravity goes straight down. That was not very straight. Let's fix that. So gravity goes directly down, Fg. We've got a normal force perpendicular to the incline, and we've got a tension force from the rope pulling the object or the box up the incline. The only force not in line with the surface is my gravitational force, so I'm going to break apart the weight into Fgy and Fgx. And this angle right here is the 26 degrees. It's the angle relative to the x-axis. Because it's moving at constant speed, I need to balance the diagram, so I'm going to make tension a little bit shorter. And normal and gravitational look like they're about the same. So my x components are equal to each other, and my y components are equal to each other. We were given that weight was equal to 40 newtons, and we're looking for the tension force. So this is easy enough. Tension force is going to equal the x component of my weight. Let's get this Ft out of the way. Okay, now I'm not out of it. The x component of the gravitational force is going to equal the gravitational force times the cosine of the angle. So Ft will equal 40 newtons cosine 26, that's a 6 degrees. Ft equals 35.95, keeps on going, newtons. So Ft is approximately equal to, with 1 sig fig, 40 newtons. The problem didn't ask for the for the normal force, but if I was looking for the normal force as well, we would just say that Fn equaled, in this case, Fgy, and then solve for the y component using sine. So the only tricky thing with inclines, and I already hammered this in, I think, in the last video with quantitative force diagrams on inclines, is that the angle you're using for theta is not the same as the angle of the incline. I already drew that out to explain exactly why, so if you forget, go watch it again. But anytime you're on an incline, you're taking 90 degrees minus the angle of incline for the theta that you'll use for this.